उसका किया था, वो वीडियो में क्या किया, रिकॉर्ड किया।
Hello everyone, a very good afternoon to all of you. Today we are going to begin with our sessions on science and technology. But before we do that, first let me just know if audio and video is fine. All good? Yeah. Please give me a thumbs up if you feel it's all good. All right, wonderful. So let's begin with our session. Now, when it comes to science and technology, what we'll do is first our first 30 to 45 minutes will be about the syllabus and the various different aspects of the syllabus, and we'll try to understand the basic strategy for science and technology. So we'll try to understand how to read the subject, because given the nature of the subject and the kind of questions that have been coming from here in the past papers, it becomes very crucial for you to understand how a question can come from this, right? So we'll try to understand all of that in the first part of the session, and then one after the other we'll go to all our chapters and we'll start dealing with all our chapters. All right. Now, so for the first 2 hours we'll do this. We'll take a lunch break somewhere around 2 o'clock, and then after that post lunch session we'll keep continuing with our session for today, and we'll take breaks as and when required after any significant topic is covered. Now, so begin with, when it comes to science and technology, the very first thing, I mean, not only for science and tech, but rather I would say for any other subject as well, the first thing that's important for you is to understand the syllabus of the subject. There are two important documents, just remember this, for any subject, anything that you're covering: the syllabus, the previous year questions. Because syllabus tells you what to cover, and the previous year questions give you an idea about how to cover, how much to cover. Because otherwise you will be going in a very directionless manner if you don't go through the previous year question papers. Now, I'm not saying that you need to know the answers to all these questions. It's just about you going through the papers and understanding the value of those papers. Now, when it comes to the syllabus in the prelims examination, the science and technology syllabus has only mentioned a very small phrase, and that is general science. Now, nobody says how general this general science is, how much detail we have to go to, what are the topics being covered under this general science. There's nothing that UPSC has said about it. So it's all going to be our assumption. And this assumption is where the previous year questions come into play, because previous year questions give us an idea and insight about what kind of questions have come in the past and what we can expect in the coming papers. Now, one thing that I've added from my end is current events of national and international importance, because this is one part from where we do see a lot of questions coming in the paper. Especially when it comes to science and technology, you might see that questions are somewhat a mix of the static and the dynamic areas, current affairs and the basic concepts. So hence current affairs, especially given the nature of the subject, becomes very crucial. And then after that, when we look at the mains syllabus, there are three important points that have been mentioned here. One, science and technology development and their applications and effects in everyday life. Now, development and their applications and effects in everyday life. Now, this is where we simply are saying that how does science impact our daily life? Anything, I mean, when you look at your life today and every part of your life today, you know that science in one way or the other is involved everywhere, right? There's nothing that is not related to science or where science is not creating an impact in your life. So that's why this is the first point. Second, achievements of Indians in science and technology, indigenization of technology, and developing new technology. Now, the first term here is achievement of Indians in science and technology. Now, one thing what it is not, is that it's not about biography of scientists. It's not that you have to make a list of all the important Indian scientists and you need to know about the life of that scientist. No, it's not a history paper. If at all a question like this had to come, it would come in your GS paper 1 as a part of historical personalities. They would never ask you a question based on the life of a scientist based on uh, in your GS paper 3. All right, so that's why it's more about the Indian scientists rather than anything else, and the achievements of Indian scientists, whether through space technology or nuclear technology or biotechnology and so on. That's what we have to understand. And then there is indigenization of technology. Now, indigenization means localization. In simple terms, I can say that it means localization. Now, look, when it comes to technology, technology could have developed anywhere. A lot of things that we use today, a lot of technologies that we use today, it's not that the technology was developed completely in India. Maybe developed in US, maybe in China, maybe in Russia, maybe somewhere else in the world, but also being used in India, adopted by India, and being used for the people of India. So that's why when you make the use of any piece of technology which is maybe developing anywhere in the world but becomes useful for us and is being used in India, then it is called as indigenization of technology. Many times we also modify technology in a manner that we can make better use of the technology. So that all will come under indigenization, and we'll see that there are a lot of things that will automatically keep coming across in all our chapters, where you will see that it is nothing but indigenization of technology. Then after that, the third point, and the third point probably is the most important point, because this is where all the important topics have been mentioned. Awareness in the field of IT, space, computers, robotics, nanotechnology, biotechnology, and issues related to intellectual property rights. Now, these are the topics, right? These are the important topics. Now, also understand that anything that has been mentioned as a part of all these topics, this syllabus has not changed for last 10-11 years. This syllabus was first introduced in 2013, and since 2013 this is the syllabus. Science has gone from somewhere to somewhere, but this is the syllabus. For example, we'll also discuss some of the topics that have not been mentioned in the syllabus, but questions have been coming from those topics. So when we look at the breakup of all the topics that we are discussing, we'll start with the first chapter of energy. Now, energy becomes a very crucial topic because the number of questions coming from energy in the past few years has increased. If you look at, especially starting from maybe 2015-16 question papers, you'll find that the number of these questions have been increasing every year. And whether in your prelims examination or in your mains examination, we expect at least one question to come from here. Now, this topic of energy is not one single chapter, but I would say a bunch of a lot of topics together, a lot of chapters together. For example, we'll discuss about coal and petroleum, we'll discuss about solar energy, wind energy, biofuels, and we'll also discuss about nuclear technology. So there are all these discussions that we'll do as a part of this one single chapter, and that's why it's a long chapter. It's going to be a long chapter, and almost entire of today's class will be only about this one chapter of energy. But important, just remember, important from both the perspective of your prelims and mains examination. Then the second chapter, space technology, again especially important, again because questions constantly come from here in both your prelims and mains exam. And I'm not only talking about the last few years, but go back in 40 years of time or 45 years of time, ever since these examinations are being conducted, and you will find that every year at least one question in space technology has been coming in your paper. So that's why it tells us the value of this particular subject, topic, that is. And that's why these two will be the most important topics and also the biggest of the chapters that we are going to discuss here. Compared to these two chapters, all the other chapters are not going to be as big as these two chapters are. And that's why I would say, and more or less I would say that entire of this weekend, today and tomorrow's class, most of the parts of today's and tomorrow's class will be only about these two topics, only these two chapters. Then after that you have biotechnology, again an important topic, again from both perspective of prelims and mains, although not as big a chapter as the first two chapters are, yet a very important topic, and again a topic from where we expect questions to come both in prelims and mains. So that's why these three topics, I would say, are important for both your prelims and mains examinations. Then after that we have some of the areas which I would say are more important for prelims. Now I'm not saying that when I say important for prelims does not mean that question in mains cannot come. Questions can come in your mains examination also, and we'll keep taking examples. We'll keep taking examples of what kind of questions can come in prelims, or what kind of questions can come in mains. What do we expect, how do we expect the questions to come? We'll keep discussing all that. All right, we'll keep discussing all that all throughout this entire journey of this entire module. So that's why just remember that whenever I say something like this, it does not mean that it is exclusive to only one examination, but rather it is something which can be important from the perspective of both your prelims and mains. But these three topics from here on, I would say that primarily they are related to your prelims examination, because whether nanotechnology, robotics and artificial intelligence, and IT and communication, their orientation, the chapter orientation is tilted towards your prelims examination. But questions in mains can come. In nanotechnology, we have seen a couple of questions. In artificial intelligence this year, I mean now last year, 2023, 23 mains paper, we saw one question from artificial intelligence. In the last class, if there is any one of you who attended my last class before 2023 mains examination, I had explicitly said there that I am expecting that a question should come in mains also this year from uh, artificial intelligence, and question did come last year. IT and communication, again, if you look at the past papers, you'll see that always questions have come in your prelims only, but it's not that questions can't come in your mains examination. Question can come there also. Now, these two chapters, defense and diseases, these are two chapters that I would say are pretty much current affairs oriented, and we expect the questions to come in your examination with the from current affairs more compared to anything else. So that's why we have to read these two chapters exclusively from the perspective of current affairs, and we'll discuss how to do that when we go to these specific chapters. And then one last chapter is intellectual property rights, which I would say that it's more important from mains perspective. But again, having said that, questions can come in your prelims, and we'll take examples. You'll understand how a question can come. That's more important for you. So these are all the topics that we are going to discuss. These are the chapters that we are going to discuss in this entire module. Now, when we look at the question paper, and when you look at the number of questions that have been coming, prelims every year, we see that at least 12 to 13 questions come, and a maximum of 15, 16 to 15 questions can come in your paper. So overall, it means that we are looking somewhere around 25 to 30 marks coming from this paper in your prelims examination. Now, understand the value of science and tech, especially in your prelims examination more than the mains examination. Why it becomes very, very important in your prelims? I've also seen that there are some platforms and some teachers who would also say that even if you don't read science, it doesn't matter, because see, 12 to 14 questions would come. You don't read science, there are 85 questions left to answer. You answer from those 85 questions and get through. I wish life was that simple, that you leave three subjects and you read the other three subjects and you'll be done. There is no guarantee. Suppose that you read one subject very well. Suppose you read geography very well, all right, and you feel that you're very strong in geography. But then five questions come from geography and 15 questions come from science and tech. What do you do then? UPSC does not tell you that, okay, we are going to ask you these many questions from this topic, these many questions from that topic, and so on. It has just given you a syllabus and it says that, look, we are going to ask you 100 questions out of this syllabus. So that's why there is now no guarantee of how many questions can come from what topic. I mean, I'm saying 12 to 15 questions. Maybe tomorrow, and maybe let's say this year's question paper, only 5 questions come from here, or maybe 25 questions come from here. There's no guarantee. There's no guarantee of how many questions. So the only thing that you can do is that you can prepare for this syllabus. Make yourself pattern proof. Don't think that okay, this year I saw this in the pattern, so next year also probably I should expect this in the pattern. There is no guarantee. There is no guarantee of what can come and what would come and what cannot come. So that's why you have to be proof of all these pattern and all these discussion about this came so that would come, that came to this would come. There's no guarantee to anything. So that's why you have to prepare for your syllabus, and this is where science and technology especially becomes important, because you do not have to give it as much time as you have to give to some of the other subjects. And I have nothing against any subject here, but I'm just giving you the pros, especially in your prelims examination for this particular subject, that why it becomes important, especially in your prelims examination, because with a very limited time that we are spending in this paper, you will be able to get 80% of the questions, or at least 70% of the questions right. And that's very important. And that's why especially in your prelims examination it becomes very, very crucial. Now coming to the mains examination, what we see is that every year 3 to 4 questions are being asked from here. So 3 to 4 questions, again you can say that 25 to 40 marks or 25 to up to 50 marks would come from this area in your GS paper 3. Now the question in the mains examination, questions are fairly easy compared to the prelims examination. The questions that we have seen at mains level are far easier, and we'll take those examples from previous papers also, where you'll realize that the questions asked in the mains examination are much easier to answer as compared to sometimes in the prelims examination. So that's why in the mains examination it gives you an opportunity to score well in these 3 to 4 questions that they would ask. Now, overall, when we look at this entire scenario, we also have to understand one basic problem with science and technology. And this is, you can say, absence of resources, absence of a book, absence of a material that you can go through. Here, that's why I'm saying that our approach has to be very different. Our approach has to be very different in a manner that whatever we are doing in the classroom, right? Whatever we are doing in the class, whatever I'm teaching you in the classroom, that becomes important. Plus, adding current affairs to this. We will discuss some of the current affairs topics also, but largely all the webinars and the daily Hindu analysis, etc., where we are covering some of the science and technology articles, they all become important. All right. So that's why uh, you have to, what I am saying is that focus on the class, focus on everything that we are discussing here in the classroom, plus all the current affairs that we give you. If you are able to do this much, it's enough for this subject. No need to go to any book, no need to go to any reference source, any other material. Just do this, the classroom, everything that we are doing in this class, plus all the current affairs that we are discussing with you. If you do this much, it will be enough for this examination. No need to be on a lookout for anything else. Now, what are our sources? First, obviously, are the newspapers. Always become very, very crucial sources. So, two newspapers, one being the Hindu and the other being the Indian Express. These two become very crucial newspapers, and one of the two, I'm not saying that you have to read both of the newspapers, one of the newspapers, if you cover, that should do it. So, that's why newspapers become important. Then, PIB. Now, in case of PIB, do you know what is PIB? Can somebody tell me what is PIB? What does PIB do? What is the significance of PIB? Okay, some of you don't know it. Press Information Bureau, correct. What does Press Information Bureau do? This PIB stands for those of you who don't know, PIB stands for Press Information Bureau. What is the role of Press Information Bureau? Anyone? Yeah, provide government information. So basically it's a platform where any new scheme, any new policy, any new initiative that is being launched by any ministry in the government, they will put out the information through PIB. So there is this website, you have pib.gov.in. This is the website. You, if you go to that website, you will see that date wise, ministry wise, every day's new announcements of policies, programs and initiatives are all done on PIB. So that's why PIB becomes an important source, not only for science and technology, but rather for any other subject also. So that's why this becomes an important source. So in case of science and technology, all the information being put forward by Ministry of Science and Technology, Department of Atomic Energy. So all these will become very, very crucial. Then Department of Biotechnology. So all this becomes important. Then the magazines, Science Reporter, Down to Earth, Yojana and Kurukshetra. Now when we look at all these magazines also become important, but this is where you can actually cover them through webinars, because in the webinars from time to time, any important article in these newspapers, we are covering them there. So even if you don't read them from cover to cover, especially let's say in case of Science Reporter, I would strongly suggest against reading it from cover to cover, because many of these articles here are irrelevant for the examination and also highly technical in nature. So it becomes very difficult for you to even read it, especially let's say if you come from a non-science background. It might make it very difficult for you to comprehend what's written there, and we anyway don't expect questions to come from these technical areas. So that's why I would suggest that don't go and read it from cover to cover. Only very specific topics have to be covered, and that too whenever required. We are doing that as a part of our current affairs sessions. Now lastly, the role of NCRTs. Now when it comes to science and technology, the role of NCRTs, I would say, is limited to somebody studying class 6 to 8th NCRTs. Class 6 to 8th NCRTs. That if you read this much, it's enough for you. If you read just class 6th, 7th, and 8th NCRTs, if you just go back to all these NCRTs, it will be enough. If you want to read further, let's say from class 9th and class 10th NCRTs, there are only selective chapters that I would suggest you. For example, the chapter on gravitation is one such chapter. So I would suggest that one should go through this chapter. Then the chapter on structure of atom. So structure of atom is one such chapter which can be important. Then there is a chapter named as fundamental unit of life. Fundamental unit of life. So this can be an important chapter. This is basically about cells and all the cellular organelles, etc. So that becomes important chapter. And then there are a few chapters in your class 10th on human body. So there are 3 to 4 chapters which are based on the human body. If at all, go through only these chapters from class 9th and 10th. Always remember, in science and technology, please don't read class 11th and class 12th NCRT books. It's not required, it's highly technical in nature. And from those of you, for those of you who are from science background, you already know this, that reading class 11th and class 12th NCRT books would mean that you need at least 1 year of time, if not more. So if you have that time that you can give one entire year only to reading class 11th and 12th NCRTs, please do that. But no question will come from there. So first and foremost, no question will come from there, and secondly, they are highly technical in nature, takes a lot of time to cover them. So please don't do that. Please don't go through class 11th and 12th NCRT books. Now the basics of every chapter, the information that we have in the NCRTs, in one way or the other, we will cover it in some class or the other. But I would still suggest that if you have time, if you can, please go through at least class 6 to 8th NCRTs. Reading class 6th and 7th NCRTs will not take a lot of time anyway. Class 8th might take a little time, but still I'm very sure that within a week anyone can read the entire NCRTs of class 6 to 8. It will help you in understanding a lot of things that you might have completely forgotten, because it might, for many of you, especially for the ones who come from a non-science background, it might have been a long time since you last visited general science. And unfortunately for many of us, the situation also is different, because when you are at school, the way science is taught is very different. Maybe you already have been given that, okay, see, this is where the questions will come from, so you just go and memorize everything, and you go in the examination, get 100 out of 100 without understanding anything. So our approach during those times has been very, very different. So that is where, I mean, when you reread it now that you are preparing for this civil services examination, you'll see that your reading abilities are very different, very enhanced also, I would say. And you will be able to extract a lot of information that you never even realized that was there in these books. So that's why I think that reading these books will help you, and it will help everyone. I mean, whether you belong to a science background or a non-science background, I would say that it helps everyone. I also want to understand one thing from you. uh, how many of you, let me just launch a poll also so that I'll get some idea. I just want to understand how many of you are from science background, commerce background, and arts background. Please mark A for science, B for commerce, and C for arts. Obviously, there is no correct or wrong answer here, but I mean, this is the only way I can conduct a poll here. So I just want to understand from your perspective. A for science background students, B for commerce background students, and C for arts background students. I just want to understand. Okay. So more than half of you belong to the science background, lesser of you belong to commerce background, and little more of you belong to the arts background. Now, one thing I should tell you, it doesn't matter. It doesn't really matter what background you belong to, because the nature of the subject is such that it will not really have an edge for anyone. I've seen this fear in a lot of people that if you belong to a non science background, it is an impossible subject for you. That's not the case, and you will realize it as we begin our discussion. And also, even for the science background students, I also want to tell uh, the ones of you that please don't be overconfident here, because many a times we have seen this overconfidence also in the science background students, that I am from science background, so I can answer any question. Just go back to the previous year papers, you'll find that you probably will not be able to answer more than half of the questions that they have asked, because the structure of the examination is such that whether one belongs to science or non-science background is taken out of the equation. So that's why I just want to tell everyone out here, that it doesn't matter what background you belong to. The only thing that matters is that whether you are attentive in the next 3 weekend classes that we have here. If you're attentive enough, the things will be good for you. So these are some of the things, I mean, from the perspective of the examination. Before we begin with our first chapter, I just want to know if you have any doubts, if you want to ask anything. Any question, if anyone has, please let me know. Is notes making required? See, what I'll be doing is that as a part of this entire lecture set, I've included a lot of information in the PPTs itself, in these all these slides itself. But beyond that, whatever is required, I'll keep writing it on the slides also, and so that those annotated PPTs can become reference notes for you. But if you are somebody who has a habit, many of us have a habit. I mean, I also do have a habit that if I'm attending a lecture, I'll have to write. So that helps me concentrate better. So it's up to you, that if you feel that you are somebody who gains better by just listening to the lectures and referring to the notes afterwards, do that, because all the notes will already be available with you and there is nothing extra that will be required. But if you are somebody who needs to write to be on course with the lectures, do that. So it's entirely up to you. But essentially, I mean, let's say if it's not that it's a rule that you have to make notes or you don't have to make notes. Newspapers are not available in our area, so you can always read it online. So it's not that you have to read the newspaper. You go to the website, there also the news articles are available for the same. You can go through that. Or if not anything, there is a daily Hindu analysis that we anyway do for you every day. Go through those sessions, that will also help you. So that's enough. Should we read all the four in magazines or Yojana and Kurukshetra enough? As I told you, that Science Reporter and Down to Earth, two magazines, I would say that they have to be, if at all they are being read, very selectively you have to read them. But even if you don't do that, you can do it from through webinars. Yojana and Kurukshetra also not cover to cover, only the parts where you feel they are covering a topic relevant for your syllabus, only then you have to read it. Otherwise, please don't. Do I need to buy NCRTs? I wouldn't say that you don't need to buy NCRTs, because first of all, NCRTs are available free on NCRT website. You can directly download the PDF from there and read it. So it's not that you have to buy the NCRTs. You can do it from there itself. Please introduce yourself. Oh, I am Rasesh Kumar. I take classes for science and technology, and I'll be the one who will try to ensure that any question that comes from this segment is not being missed in your prelims and mains examination. Running notes help easy to recap. That's what I said. That, I mean, it actually differs from person to person. I mean, I would agree with you because I have a habit of doing that, but many of us do not have that habit, and they can read through the lecture notes later, and so that's why it's a personal choice altogether. Preparing for 2026. So if you're preparing for 2026, then in that case, the all the things that we're doing here in the classroom will still remain relevant until 2026 also. But just that there are some current affairs parts that I'll deal with from time to time. Some of that current affairs may become not important by the time you are in 2026 paper. So how about Kurukshetra? So see, in case of Kurukshetra, the number of relevant articles are pretty less compared to in Yojana magazine. So that's why you have to be very strict in picking those articles and don't just try to read everything that you have. Can we rely on lecture notes and webinars for prelims? Precisely what I've been saying, that just focus on what we are doing in the classroom. I will ensure that you do not have to go elsewhere just to read a book or just to read another resource. I'll keep covering everything that's required for the examination, plus adding current affairs to it will be enough for this subject. Required to watch your tablet like recorded videos? Not required, because these lectures anyway, you can say, will be more updated than the tablet lectures, because some of those lectures have been recorded a few months back or a year back. So that's why it's better if you can just focus on these classes. Only four lessons to be studied from ninth and 10th. Yeah, only these four. I mean, first three are one single chapter. The fourth part actually is a bunch of three chapters. So overall, you can say three, 3 plus 3, 6 chapters from class 9th and 10th combined. Is this relevant to 2025? Yes, of course it is. I mean, these areas, they are covering the basics for everything. So whether 2025, 26, 28, it will remain important. So that's why just remember this. What type of questions came from space technology? We'll discuss that. Let me go to those areas, then I'll discuss this. Could you tell me when the new batch for the year 2024-25 is going to begin? I think next week onwards, I mean it's February onwards, I think we are beginning with the new batch. So you will be informed about it. Don't worry. Can I skip energy chapter? What kind of question is this? You are saying that the chapter from where the most number of questions will come, are you, and you are asking me whether you should skip the chapter. Hmm. Is there any need to read the books provided by Byju's? Not required. That's what I'm saying. That just focus on the class. Class, all the notes, all the additional reading material in the class. That's it. Plus current affairs. Done. No book, whether given by Byju's, whether given by anyone else, whether available in the market, not required. Right. So let's begin with our discussion. The first chapter that we have is energy. Now, when it comes to energy, understand first and foremost what do we mean by energy. How do we define energy? We say that energy is the capacity to do work. All right, the capacity to do work is called as energy. Now, in this regard, so energy basically is the capacity to do work, and we measure this in joules. The unit that we use for measuring energy is joules. Now, capacity to do work, any kind of work that we do, we know that we need energy for that, right? We need something that will provide us enough energy, enough force, so that that work can be done, can be completed. Now, in this regard, we see that energy, there are various different sources of energy. There are various ways in which we can generate energy. So whether it is heat energy, that is called as thermal energy, or light energy, or nuclear energy, or mechanical energy, potential energy, kinetic energy, there are various different ways in which can look at energy. And that's why it exists in various different forms. It exists in many forms. Now, in case of energy, first thing that is important and what we are going to discuss in this classroom is how are we getting this energy? Where are we getting that energy from? And that's where sources of this energy becomes very crucial, because ultimately what matters is how are we getting enough energy so that whatever this country needs, we have those sources, we have that kind of energy available. So that is where we need to understand the role of energy. Now, when it comes to all these sources of energy where we are deriving enough energy from, this is where we see the role of first classifying and understanding the various forms of energy. Now, overall, when it comes to energy, there are two ways in which we classify energy: one on the basis of renewable and non-renewable energy, and second on the basis of conventional and non-conventional energy. Now, when it comes to first classification, that is between renewable and non-renewable, understand the difference between what is renewable and what is non-renewable. Now, as the term suggests, that this is renewable energy. Renewable energy, meaning what? That I can renew this energy, right? I should be able to renew this energy. That's why it is renewable energy. Now, if let's say I'm renewing energy, let's say suppose I have an energy source that I can renew in 50 years. Should I call it as renewable? What do you think? Should I call it as a renewable energy source? If in 50 years some energy source is getting renewed, the answer, as most of you have suggested, would be no. I shouldn't call it as a renewable energy source, because renewable energy is supposed to be the kind of energy that can give me a constant supply of energy. constant supply of energy. It shouldn't be the fact that today, let's say for example, suppose that you had an energy source that can be replenished in 50 years, that today energy is available, after this again in 50 years it will recharge, and then again it will be available. You cannot wait. Can you wait? You can't wait. So because if you need electricity, for example, you need electricity all the time, you would want that there is a 24-hour supply of electricity, correct? So we cannot rely on these sources as renewable sources if, let's say, it is taking some time before that, before which it can be renewed. So that's why this is one thing that becomes important about renewable energy, for us to understand that this should be the kind of energy which we should be able to renew, and our replacement rate should be higher than our consumption rate, right? In renewable energy, this should be the energy form where replacement rate is higher than the consumption rate. Replacement rate is higher than the consumption rate. Now, overall, when it comes to, that's why just have to understand that when we say that replacement rate is higher than the consumption rate, meaning that by the time you consume energy, you should have new bouts of energy available, so that energy is not getting finished. You don't have to wait to get that energy back. And that's why when you look at the sources that you have of renewable energy, we have solar, wind, geothermal, and biofuels. All these are sources that have a constant supply available, and they can exist for as long as the earth exists. For as long as the earth exists, these sources of energy will also be available. So that's why these are renewable sources of energy. On the other hand, we have non-renewable energy sources where you have coal, petroleum, and natural gas. Now, coal, petroleum, and natural gas, when it comes to these three sources of energy, what happens is that these are sources which, once consumed, we will not be able to replenish it. It has taken a lot of time for the formation of these sources to happen, and we have consumed it in no time compared to that time. So, for example, if you think of coal, we almost have exhausted coal in the last 300 odd years. You can say that since industrial revolution we started using coal, right? Industrial revolution we started using coal in a very big manner, you can say at a larger scale, only in 300 years. Now, for example, estimates for India says that India has almost 130 to 140 years of coal left. That's it. That's the estimate, that in the next 100 odd years we will already be done with coal. So then in that case it's not enough, because formation of coal has taken a longer time. Do you know how much time it takes for coal formation to happen? Any idea? Any guesses? Hmm. Some of you have given the exact correct answer. It takes, yeah, it takes almost 300 million years, right? 300 million years. To consume it, we have taken 300 years. To form, for formation of coal, it takes 300 million years. So that's why you have to understand that here the replacement age rate is much lower as compared to the consumption rate. So that's why these are non-renewable sources of energy. Now, in this regard, when it comes to the classification between renewable and non-renewable, I haven't mentioned a very, very important source of energy, and that is nuclear energy. Now, let me ask you first: is it renewable energy or is it non-renewable energy? What do you think? Whether nuclear energy is renewable or is it non-renewable in nature? As expected, half of you are saying renewable, half of you are saying non-renewable, and both these halves are correct. That we can classify renewable it as renewable energy, we can classify it as non-renewable energy also. Now understand the difference here. Understand why am I saying that it can be said to be renewable, it can be said to be non-renewable. The current status of nuclear energy is that we are dependent on uranium, right? We are dependent on uranium, and from uranium we are getting nuclear fission energy. We'll discuss all these details later when we go to nuclear technology, but just know as a basic information that we are using what? We are using uranium. Now uranium is also just like coal, etc., that it is present in a limited amount inside the earth, and we are mining that uranium and we are using that uranium as a source. So as long as we are only dependent on uranium and we have only few types of nuclear reactors, I would say that it is non-renewable energy. But then comes the future, and then comes some of the other types of reactors. There are certain reactors that will enable you to use the same nuclear fuel for a very long time. They'll be able to produce more nuclear fuel than the amount of nuclear fuel that they're consuming. They're called as breeder reactors. We'll discuss about all these things later. So, and then there is nuclear fusion, where we want to use hydrogen as the source of energy. In all these cases, if we are able to achieve the successes in these cases, then it becomes renewable. Then in that case we can keep using nuclear energy for as long as we want, and then at the same time it also becomes a clean source of energy at a later stage. Right now with uranium and the kind of operations that we have, a lot of radiation pollution is associated with this, but in the future the things that we are working on, it will be a much cleaner source of energy. So that's why from both the aspects you have to understand that right now it's very difficult to clearly define it as either renewable or non-renewable. So that's why if a question comes in your prelims where it says whether it is renewable or non-renewable, just leave the question and go to the next question, because there is no way to uh, guarantee what thought process would have been behind asking such a question. So that's why nuclear energy can be renewable, can be non-renewable, depending on various factors. All right. So right now there is nothing that we can do about it, and we'll discuss about all these things later when we go to the chapter on nuclear technology. The second way to classify energy is on the basis of conventional and non-conventional energy. Conventional, the ones that we have been using traditionally, which we have been using for a very long time, we'll say that these are conventional sources. So you can say in a manner coal, petroleum, etc., they are conventional sources. The other sources have been the domestic energy sources like firewood, straw, or dried dung, etc. Then non-conventional sources are the sources that we just started using. We have started or we have figured out how to use it just maybe a few decades back, and these are called as non-conventional sources. So this is where you have solar energy, wind energy, geothermal energy, and biofuels, and all these are called as non-conventional sources of energy. So because only few, you can say, decades back we understood how to use them commercially. All right, so that's why these are non-conventional sources. So overall this is how we classify energy on the basis of first renewable and non-renewable energy, and second on the basis of conventional and non-conventional energy sources. Now what you will find is normally all the sources which are renewable, they are non-conventional in nature, and all the sources which are non-renewable, they are conventional in nature. But that's not a rule. There are exceptions to it. For example, there are sources which are non-conventional and non-renewable at the same time. For example, we'll discuss about this also later, shale gas or coal bed methane. These are sources which are non-conventional and non-renewable both at the same time, and we'll discuss the reason why we are saying that. But normally what we see is that all the conventional sources are non-renewable sources and all the non-conventional sources are renewable sources. Now what we are going to do is that we are going to first discuss all the non-renewable sources. We'll discuss about coal and petroleum first, and then after that we'll also discuss about shale gas, coal bed methane, methane hydrates, HCNG, and all these kind of things which come under the bracket of non-renewable energy. And then after that, we'll move on to our segment of renewable energy. We'll discuss about what is solar energy, what is wind energy, what are biofuels, what is geothermal energy, and so on. And then the last part of our discussion will be about nuclear energy and nuclear technology. So you can say, in a manner, these are the three units of this one chapter that we are going to discuss. First, to begin with, we have coal. So we'll start our discussion with coal. Now, when it comes to coal as a source, understand what is coal and what are the ways in which we are using coal today. By definition, what we are saying is that coal is a fossil fuel, right? Coal is a fossil fuel, and we are talking of it as altered remains of prehistoric vegetation that originally accumulated in swamps, largely meaning the wetland areas. So, fossil fuel, we'll say that it is a fossil fuel and altered remains of prehistoric vegetation. Now, what do we mean by fossil fuel? The meaning is that it is something that comes from the remains, prehistoric remains of something. Now, in case of coal formation, we are saying that comes from prehistoric vegetation. It comes from prehistoric vegetation. So, when it comes to the formation of coal, we see that the formation of coal would have begun 360 to 290 million years ago. This is when it would have started developing. All right, this is when the formation would have begun. Now, overall, what may have happened at that point of time is that whatever coal, I mean, whatever vegetation we had, vegetation in the swamps, vegetation in the wetlands, they started to get submerged under land due to some reason. Maybe because of geological reasons, maybe because of seismic reasons, one reason or the other, they started to get submerged under land. And as they get submerged under land, this is where they also mix with a lot of sediments, and mixing with the sediments, being submerged, they now see high temperature and high pressure. All right, they see high temperature and high pressure. Now, under these conditions of high temperature and pressure, this is where we see that uh, they start to change chemically. That all this vegetation that we had, now this started to chemically change under the conditions of high temperature and high pressure applied on them over a period of time. Because as you go down below, as you go beneath the earth, the temperature rises, temperature of the core is very high compared to the temperature up above. So that's why temperature at the core is very high and it applies a lot of pressure as you are buried deep underground. So this is where we see that this prehistoric vegetation starts to chemically change into coal, and ultimately it would convert into coal entirely. And depending on how much heat, how much pressure they were put through, depending on that and for how much time, we ultimately see that they would completely change. They would change. And depending on how much temperature and pressure for how much time also determines what kind of quality is developing in them. What's the quality of coal completely depends on what kind of how much pressure and how much temperature they would put through for how much time. So that's why peat is when you have not very high temperature, not very high pressure for a lesser duration of time. Lignite, a bit more temperature, bit higher temperature, bit more of pressure for a longer duration, and then bituminous and then anthracite. Now, in all this, what we observe is when we look at all these different types of coal, first, for example, peat. If you look at the appearance of peat, you will see that it has a woody appearance, like looks like a bark of wood. If you look at the picture, bark like a bark of a tree, correct? So why it has such an appearance is mainly because a complete conversion into coal did not happen. And that's why even if you see many of the reports and how coal ministry looks at peat or how coal India looks at peat, you'll see that they say that peat is different from coal, because peat is not even usable in a lot of ways, because it has very high amount of impurities, a lot of pollution they would cause, and overall the heat that you can extract out of peat is very less. So that's why They don't even use it in industrial applications for electricity, or maybe in iron and steel plants, etc., fertilizer plants. In all these cases, peat is rarely used. Peat has more applications in agriculture, and filtration. So these are the things that we try to use peat for. Then after that, we have lignite. Now lignite, as you see by its appearance, it seems to be blue, brownish in color. That's why many a times it is also called as brown coal. It is also called as brown coal. And one thing about lignite is, yes, it also has a lower quality, because again conversion did not happen as good as it has happened for bituminous or anthracite. So but it is still usable. We do see that in some applications, in some of the even let's say some electricity production also, we sometimes do use lignite. So lignite can be used in this manner. Now one aspect of lignite is something which is called as spontaneous combustion. Spontaneous combustion. Now what we mean by spontaneous combustion is that lignite, especially lignite, may sometimes catch fire on its own, in especially in the mines. In the mines, when the mining activities are being done, this is when we see that sometimes lignite can lead to fire accidents, where what happens is that you have this lignite at tremendously high pressure, at high temperature, where the formation happened, but it was completely cut off from any supply of oxygen. Now for any kind of combustion to happen, for anything that starts burning, you will always see that.
5 मिनट के लिए जरा रोहित से बात करेंगे।
अच्छा,
वो क्लास कैसे चल रहा है कोई ऑफिस में?
just give me 5 minutes. There is some issue somewhere. Just hold on for 5 minutes. Let me just check. We're trying to resolve the issue for some of you that you're facing. Just give me some time. I know that half of you are going getting the session. Let's be back by 1:15. We're trying to solve the problem. Let's be back by 1:15. And by the time, for those of you who are facing the issue, we are trying to resolve that issue. Hi everyone. Please tell me first if audio and video is fine for everyone. It's good, clear. Okay. Now, so we were discussing about lignite, and what I told you about lignite is that lignite has a capacity that it can undergo spontaneous combustion. Now, when we say spontaneous combustion, meaning is that it can catch fire on its own, and many a times we have seen that it becomes a cause for fire accidents in the coal mines. If you go back into the history, you'll find that in lot of coal mines in India, even if you go to post independence era, you'll find that in 1950s, in 1960s, there would be coal mines there are where we have seen fire accidents, and unfortunately a lot of miners, they lost their life to these kind of accidents. So now when it comes to these fire accidents, one of the primary reasons has been the presence of lignite. That there are chances that all of a sudden, when lignite gets a gush of oxygen, when you mine into, let's say, a coal mine, so until now, what happened was that the oxygen supply was completely cut off from coal, correct? But now, as you dig the mine, you are now providing that oxygen which was completely absent until now. Now, as soon as you provide this oxygen, combustion, you might know that any kind of combustion needs oxygen. That even if you are lighting a matchstick also, the matchstick is able to catch that fire only because there is oxygen in our atmosphere. If our atmosphere did not have oxygen, then this simple combustion also wouldn't happen. So any combustion needs oxygen, and here what happens is that it already has high temperature, has high pressure, and all of a sudden, as oxygen supply is made, it can catch fire and it can become very dangerous in the coal mines. Now we have mechanisms to ensure that these accidents can be minimized as much as possible. But in the past, you'll see that the things have been very unfortunate, whether in India or even in China, because China also has huge amount of lignite deposits, and that's why in China also a number of fire accidents used to happen in the past. So this is where we see that spontaneous combustion is a factor, especially in case of lignite. Then we have bituminous. Now, in case of bituminous, many a times it is also called as industrial coal. We also call it as industrial coal. Now, why we call it as industrial coal? The meaning is, the reason is that most prominently, bituminous is the kind of coal that we use as in the industries, whether it is electricity, whether it is fertilizer plant, whether it is iron and steel industry. You'll find that in all these cases, bituminous is the kind of coal which is most widely used. All right, most widely used form of coal. So that's why it is sometimes also called as bituminous coal. And when it comes to India, bituminous is the kind of coal that India has in vast reserves. The largest quantity that India has is of bituminous coal. And then lastly, we have anthracite. Now, anthracite is the best variant of coal. The amount of carbon in this coal is very high. The amount of impurities here is very low. That's why the efficiency is very high. It is very clean in its burning as well. So, but anthracite, uh, India, for example, we do not really have anthracite in large quantities, very small quantities. US has predominantly the most uh, uh, highest amount of anthracite reserves. So overall, just remember that these are the types of coal. Just to do a basic analysis between these all types of coal, peat has the lowest carbon content, right? Lowest carbon content. Normally, we see that this is less than 40%. It has less than 40% carbon, and largely it is all these impurities that we have here. Then after that, you have lignite. Now lignite, we see that carbon percentage is between 40 to 55. It has 40 to 55% carbon. In case of bituminous, we see that the carbon content is higher. It is in the range of 55 to 80%. And in case of anthracite, it is the highest. It is in the range of 80 to 95% carbon. So that's why highest percentage of carbon is seen in case of anthracite, and the lowest is seen in case of peat. Efficiency wise, that's why we'll see that peat has the lowest efficiency and anthracite has the highest efficiency. directly dependent on the amount of coal that you have, sorry, amount of carbon that you have in coal. And that's why the ash and volatile content, or the impurities in short, highest in peat and lowest in anthracite. Now, when we look at the usage, we will find that largely when it comes to the industrial use, it is basically bituminous, but also we can make the use of lignite also in these cases. But we prefer the use of bituminous over lignite for a very simple reason that lignite can be very polluting. It can be very highly polluting because carbon content is lower side, right? So that's why it can be highly polluting, and hence we do not prefer the use of lignite. Once in a while, although we do see the use of lignite whenever we are falling short of bituminous, in those kind of cases, we might see the use of lignite instead of bituminous. But it is largely, we try that we don't have to use it. Anthracite obviously is the best variant used in smelting of ores. It can be used as a fuel and also is used in heating systems, etc. So in all these cases, these are the different types of coal. Now, when it comes to the distribution in India, what we see is that the highest reserves that India has is concentrated in these three states: Jharkhand, Odisha, and Chhattisgarh. Jharkhand has the highest coal reserves in India. Now, overall, when it comes to the coal reserves in the country, you'll see that there are various different types of coal that are found in various different parts of the country. So, for example, central part, this central part is where you would largely find bituminous coal. Central part is where you will find bituminous coal. Then this part is where we largely find peat. Now, it does not mean that other variants of coal are not found here. For example, with bituminous, we do find lignite also mixed in a lot of cases, but largely it is bituminous. Then, this is the part where we have the presence of anthracite. In Jammu and Kashmir, and these areas in Rajasthan, in Gujarat, in Tamil Nadu, in Puducherry, even in parts of Kerala, in all these cases, we see that this is where we find lignite. This is where we find lignite. So this is how we see the coal distribution in India. But just remember that the central part where you have Jharkhand, Odisha, Chhattisgarh, and also the states of Maharashtra, Telangana, Andhra Pradesh, West Bengal, even parts of Uttar Pradesh and very small portion of Bihar, we see that these are the areas which largely have bituminous coal, and the most amount of reserves that India has is concentrated in this part of eastern central India. Now, overall, when it comes to the coal reserves, we have been among the top producers of coal, and that's why we have been using this coal mainly for electricity generation. Now, if you look at the data today, what you will find is that the large amount of electricity that we produce, we are actually producing this electricity through coal. As per the data, if you see, right now almost 55 to 60% of electricity 55 to 60% of electricity comes from coal. All right, 55 to 60% of electricity comes from coal. Now, so that's why India is highly dependent on coal for its electricity. Although we have been trying to also involve all the other types of resources, but we are still dependent pretty much on coal. 5 6 years back, this data used to be more than 70%, that more than 70% of electricity in India came from coal. But now we see that there is small improvements happening, and hence we have been able to decrease our dependence on coal, and now it has come down to almost 55 to 60%. Now, India has a target, the government has a target that by 2030, our dependence on coal and all the other non renewable resources should come down to less than 50%. This is what we are working on. But currently, almost 55 to 60% of electricity still comes from coal. Now, in case of coal, our reliance on coal is heavy, but we need to understand the problems associated with coal. And this is where first thing is about coal ash. Now, coal ash is nothing but the residue, the leftover. When the coal is burnt, when the combustion of coal happens, the leftover is called as the ash. Now, in this case of ash, most importantly, and the most, you can say, the most problematic part of this entire coal ash is something which is called as fine ash. Something which is called as fly ash. Now, this fly ash is very fine powder of leftovers of after the combustion of coal, and it is very light in weight. It can even get out of the coal chimneys. I mean, the chimney, the the furnace through smokestacks. So it can just go out with the smoke. And these are very fine powdered material, very fine particles, and that's why they contribute to air pollution a lot. At the same time, they can also go and deposit in the nearby areas. So can deposit on water bodies, can deposit on land resources, on the let's say agricultural land, and it can negatively impact the soil health as well. So overall, it can create a lot of issues for us. All right. So that's why fly ash contributes to air pollution, to water pollution, to land pollution, all at the same time. Then there are bigger materials, also bigger pieces of ash, which are also called as bottom ash. These are called as bottom ash. Now, why we call them as bottom ash is mainly because they get deposited at the bottom of the furnace. All right, so they get deposited at the bottom of the furnace, and hence they are also called as bottom ash. Now, in case of bottom ash and fly ash, what we see is that fly ash becomes a bigger concern for us, because fly ash can just mix and go and mix with the air, water, and soil, and hence it's a bigger concern for us compared to bottom ash, which gets deposited at the bottom of the furnace. So that's why it is easier to remove and then dispose. So that's a disposal wise easier to dispose when it comes to bottom ash. But in case of fly ash, it can be a big problem for us. So when it comes to coal ash, basically it is nothing but the coal combustion residuals, which is produced from the burning of coal in the coal fired thermal power plants. Now, when it comes to coal ash, it has a lot of different materials that can be very harmful. For example, it can contain lead, arsenic, mercury, cadmium, uranium, and all these. So basically a silica material, but at the same time a mix of all these different types of uh, harmful elements. So that is what makes coal ash poisonous, especially when it comes to fly ash, which can just go and deposit and just fly for a very long time because they are so light in weight. It becomes a very uh, uh, big cause of concern for us. So overall, when it comes to fly ash, it is a fine powdery silica material created when fine coal or pulverized coal is burnt. Now we are talking about pulverized coal. Pulverization is a method that we use in coal fired thermal power plants, where what we do is that we, when you are mining coal, you have big blocks of coal, big stones, you can say, of coal, and then you have to just crush it. We just convert these big blocks of coal into fine powder, and that is called as pulverization. So pulverized coal, that's why it is called as the fine powdered coal. So that's why the combustion of this fly will create a lot of fly ash. Then after that we have bottom ash, which are bigger particles, bigger chunks, more coarse material. Sorry, spelling mistake. COARSE. So ash particles that forms at the bottom of the coal furnace. So that's why easier to remove, easier to dispose of. Apart from this, also there are other types of coal. For example, we have boiler slag and we have flue gas desulfurization material. Now, boiler slag is a specific type of bottom ash which is in molten form. It can be in its molten form, and this is where it is composed of a lot of different types of oxides: silicon dioxide, aluminium oxide, iron oxide, calcium oxides. So, all these oxides can be mixed here. but it's very small in quantity compared to the amount of fly ash that we are generating. This is very small in quantity, so that's why not a big cause of concern for us. And then lastly, we have flue gas desulfurization material. Now this is where what happens is that whenever coal combustion is happening, treatment of coal is also done so that less amount of sulfur dioxide is produced or emitted. And we know that sulfur dioxide is a big air pollutant, so that's why we do not want sulfur dioxide in this mixture, and hence we go through a process which is called as desulfurization. Now because of desulfurization also, we see that some amount of coal residues are produced, and that's why it is called as flue gas desulfurization material. And primarily it is composed of calcium sulfate dehydrate, that is also called as gypsum. So there are all these kinds of ashes that we have, but just remember that the largest contributor here is fly ash. So that's why it becomes very essential for us to understand the decomposition, or sorry, rather the disposal and the recycling of the coal ash. Now, in this particular scenario, when it comes to coal ash, what we see is that if we have to get rid of them, if we have to dispose them, they can be disposed of either as surface impoundments or in case of landfills. So we will just dig up the land, and coal ash will be filled with it, and we will just cover it from above. So that's one way of getting rid of fly ash. The other way that we use is to use the abundant mines. All the mines where the mining activities are done, no more mining is happening, in these kind of areas also coal ash will simply be filling up all these areas. So that's another way to dispose. But when it comes to recycling, we see that there are various ways in which we can recycle fly ash also. One way can be to mix with cement. It can be mixed with cement and can be used in construction activities. At the same time, if you have seen bricks like these, the color, you might have seen this kind of a brick whenever construction wherever is going on, instead of red bricks, right? So these bricks also, they have a mixture of fly ash in them. So fly ash, one way in which we can recycle it is by using them in bricks or in construction activities, or even by uh, mixing it with the bitumen in road construction. So in making roads also, many a times fly ash can be mixed there, and that also becomes one of the ways in which it can be recycled. So there are various ways in which we can make the use of fly ash and recycle it. And when it comes to bottom ash, it can also be used as a stabilize and also to fill or control the snow on roads. So this is how we can recycle or dispose fly ash. One more topic of importance, and especially when it comes to current affairs, from the perspective of current affairs, is coal gasification. Even yesterday it was in news. Yesterday also it was in news that total day before yesterday's newspaper, if you go to the Hindu, you'll see that it was in the news that a total of 8500 crores is being given by the government for coal gasification in India. And it has constantly been in the news for the last 2 years. And that's why I believe that for your examination, coal gasification as a topic is going to be very, very important. Now, when it comes to coal gasification, understand what we mean by coal gasification. This is nothing but a process of converting coal into synthesis gas. Now, synthesis gas, which is something sometimes also called as synthetic gas, also in short called as syngas. So whether syngas, whether synthetic gas, whether synthesis gas, they all have the same meaning, where we are talking about converting coal into gases. And these gases basically primarily they are a mixture of hydrogen and carbon monoxide. Hydrogen and carbon monoxide plus some amount of small amount of carbon dioxide, right? Small amount of carbon dioxide mixed with hydrogen and carbon monoxide. So all these basically are mixed in syngas. Now this syngas can be used in various different purposes. This syngas can be used, it can be used in electricity generation. It can be used in various, you can say, chemicals also, manufacturing of various chemicals also. So for example, in fertilizer industry it is used. So in manufacturing of fertilizers also it is used. So that's why it does find its use in various different applications. Now, overall, what happens in coal gasification is that here also the coal will have to be heated. Then only you can convert it to gas. But here the heating that we do is done at a very significantly high temperature. Normal combustion that happens in the thermal power plants, in the coal fired thermal power plants, that happens at 350 to 400 degrees Celsius, whereas in case of coal gasification we go to around 1200 to 1500 degrees Celsius. So that's why we raise this temperature to a very high temperature, and there only we see that gasification is done at very high pressure, and that too in the presence of steam and oxygen. So overall, that's why this gasification process is different, and hence the chemical process being different also means that there is a different chemical composition that we produce instead of a normal combustion of coal. Now in this particular scenario, when it comes to coal gasification, understand why are we talking about coal gasification so much. Because what was in the news initially was that government is considering a total of 6,000 crore worth of coal gasification scheme. And very recently, just a couple of days back, we have seen that a total of 8,500 crore rupees have been given for coal gasification process. Now overall, just understand what we are doing here. What we want is that new coal gasification plants be built in India, and we should start using coal gasification for electricity production instead of using the normal combustion process that we use currently. Now, understand why. What are we trying to do here? There are two things that we want. One, to increase our capacity. Whatever capacity we have, we want to increase that capacity. And second, we want to increase our efficiency also while being cleaner. This is very, very important, because coal gasification as a process is cleaner than the normal combustion, than the normal usage of coal in coal fired thermal power plants. So that's why the carbon dioxide emissions will be lower, efficiency is higher. So, and you will be able to add it to the normal or the existing capacity. So that's why we are looking at coal gasification as a process. So first advantage, that's why it will be cleaner burning, that we see that in the result pollutants like sulfur dioxide or nitrogen oxides, particulate matter, etc., will be absent. So that's why it will be cleaner as compared to normal combustion of coal. Then it has a better efficiency, and the conversion capacity goes up to 95%. Up to 95%. The normal combustion that we do has an efficiency of up to 33%. So that's why it has a huge efficiency gap as compared to the normal or the present ways in which electricity production happens through coal. Then it also is versatile, and something that we discussed, that syngas can be used in various different ways. Syngas can be used for electricity generation, syngas can be used in various chemicals, etc. So that's why it can be used in various ways, and that's why we are saying that it is versatile in nature. Then reduced environmental impact, it has a cleaner burning, so hence lesser pollutants, so better for the environment. And lastly, it helps us in enhancing energy security, because just remember, as we discussed, that it is going to increase our efficiency, and that's why reduce the dependence on foreign oil and gas. So these are some of the advantages that we have from coal gasification, and that is the reason why the government has been considering that going forward coal gasification is how we should produce energy. Now let me give you just one question. This question was asked in your 2019 paper. Read the question. I will also launch the poll for you so that we can understand where you are. I'm launching the poll. I hope that you've read the question. Please mark your answers. It's an easy question. So I hope that most of you get it correct. I see that some of you have questions. Whenever we take a break, I'll tell you when to ask your questions. So if at all your questions are unanswered, please ask your questions during that gap so that I'll answer all your questions. Hmm. So 67% of you have marked A, which is the correct answer. But let me just discuss this with you. With reference to fly ash produced by power plants using coal as fuel, which of the following statements is or are correct? First, fly ash can be used in production of bricks for building construction. We discussed this, we saw the picture also. So, definitely one is correct. Fly ash can be used as a replacement for some of the Portland cement in the and the concrete contents of concrete. Correct? We discussed that in construction activities we do make the use of fly ash and we mix it with cement in construction activities. So this is also correct. This is also something that we can do. Third one is fly ash is made up of silicon dioxide and calcium oxide only and does not contain any toxic element. The entire discussion that we are doing is mainly because of toxic elements. We discussed that there are so many toxic elements that we have in fly ash. So that's why this is wrong. So correct answer will be only 1 and 2. Right? So if you have any questions from whatever we discussed about coal, please let me know. Any question if you have. How to control snow? So basically what happens here is that when you use bottom ash is a very good absorbent. So what wherever you use bottom ash, it will be able to absorb a lot of moisture very easily, and hence we say that it will be able to control snow. Please give poll we had given. I mean, there are so many people who had marked the answer also. What is smelting? Smelting basically is when it comes to the iron ores and how we basically from the iron ore, I mean, sorry, not iron ore, metal ores. When from the metal ores, when we are extracting the metal. So you might know, just for example, let's say if you have bauxite. So from bauxite, we uh, get aluminium. So getting that aluminium from bauxite, that kind of a method is called as smelting. Why anthracite is also called as blind coal? It is called as blind coal because it does not produce any pollution. It burns with a blue flame, almost you can say smokeless flame, and that's why it is called as blind coal. Please explain the term indigenization of technology again. So indigenization of technology is when we adopt a technology for our needs. So let's say any technology that elsewhere has been functioning in India, it would be modified according to the requirements that we have. So that modification or that usage, so that we are tailoring it according to our requirements, is called as indigenization. Leaderboard I'll show you towards the end once we are done. At the end, whatever questions we have, I'll show you the leaderboard for that. Fine coal is nothing but the powdered coal that we are using. So that's why it is fine, or it is basically where we are able to increase the combustion activity. We are able to increase the efficiency of combustion by converting it to powdered coal. So that is what fine coal is. Two terms related to coal explained in slide. Which two terms? I'm not sure. Is India using coal gasification? At a very small scale, we are, but we want to increase our usage of coal gasification and extend it to using it in electricity production. Coal and charcoal. So, see, between coal and charcoal, the basic difference is that coal is a mineral and you get energy directly from there. Whereas when it comes to charcoal is artificially produced by, you can say, half conversion or incomplete conversion of wood. All right, so partial combustion of wood would convert it into charcoal. So there is a specific method that we use in converting it. So that's where we see that the process that we largely use in case of charcoal is pyrolysis. That we'll use the process of pyrolysis, where we'll heat that wood uh, at extremely high temperature and pressure in the absence of oxygen, and produce charcoal from there. Do you have any information regarding the evening classes when it is going to start again? I'm not sure what is going on in evening class right now, but I think some batch in air evening class is running. I'll check it with the support team. They might be better suited to answer this. Lithium batteries come under what energy? See, lithium batteries or any kind of battery technology is a medium term solution. That you cannot really say that it is renewable completely, because you are dependent on some metal or their properties to get that energy. But it is cleaner as compared to coal and petroleum. So that perspective, we see that it is seen as a medium term solution. But you cannot keep it as renewable. It is largely kept as a clean source of energy. In a hypothetical state, if all the coal is consumed, will there be any environmental impact? It will. It will have a significant environmental impact, and it has shown a lot of impact, because you will be releasing a lot of carbon dioxide into the atmosphere. That leads to greenhouse effect. That leads to global warming. So global temperatures will rise, and it will lead to climate change altogether. Is it we get aluminium from bauxite? It is smelting of aluminium or smelting of bauxite? It is smelting of bauxite, because bauxite is melted and basically heated and melted. That is smelting. What is that smelting is that it is heated and then melted, and from there on we get the metal. How nuclear energy is both renewable and non-renewable, please explain again. So what I said is that in case of nuclear energy, when we look at the current state and where we are making the use of uranium only, then in that case it is non-renewable, because uranium is also a mineral which is available in limited quantity inside the earth. So one day uranium will be exhausted, and then we will not have nuclear energy anymore. But there are ways in which we can make it renewable. For example, right now there are so many experiments happening around nuclear fusion. So once nuclear fusion becomes a reality, then with very limited amount of hydrogen, you will be getting enormous amount of energy, and hence you can then say that it becomes renewable for us. And then at the same time, there are certain reactors about which we'll discuss later, and these reactors also have a capacity to make nuclear energy usable for a very long time. So then in that case, they would start shifting towards being renewable. All right. So next is petroleum. Now it's 2 o'clock. Shall we take the lunch break here itself? What do you need? What do you say? Or should we complete another topic and then take the break? So most of you want this topic to be completed first. So let's do this. I mean, it will anyway not take more than 15 to 20 minutes. Let's complete petroleum, and after petroleum, let's take the lunch break. All right. So let's move on with petroleum. Now, in case of petroleum, what we basically are saying is that petroleum is a complex mixture of hydrocarbons that occurs in the earth. So, complex mixture of hydrocarbons that occurs in the earth in solid, liquid, or gaseous form. And this is also a fossil fuel. Now, again, when it comes to petroleum, we know that petroleum also is a fuel. Petroleum is something that we use in various different forms, whether in vehicles or in other ways. So now in case of petroleum, we are saying that it's a complex mixture of hydrocarbons. Now just understand the basic difference between coal and petroleum. Similarity wise, we know the similarities. Both of them can be used as fuel. Both of them, you can in a manner say, they run the world economy right now. Right? So they run the world economy. Both of them are uh, used as fuel. Both of them are fossil fuels because they are coming from the remains of prehistoric organisms. So both of them are that, and both of them obviously they are highly polluting in nature and also contribute to global warming. So that's why these are some of the similarities that we have between coal and petroleum. But at the same time, it's also important for you to understand that when it comes to the composition, the chemistry, they are very different. So coal and petroleum, you'll find that there are a lot of differences between coal and petroleum. So first, for example, let's say on the basis of the origin. On the basis of the origin, what we have discussed about coal is that coal basically comes from where? It comes from prehistoric vegetation. Prehistoric vegetation. Whereas in case of petroleum, the origin, or not origin, let me call it as the source. So source for coal is prehistoric vegetation, whereas for petroleum, it would have been algae and zooplanktons. Algae and zooplanktons. So in a manner, you can see a difference here, that coal is completely based on plants because it's only vegetation, whereas petroleum formation has happened both from plant and animal sources. Right, they've happened from both plant and animal sources. So in a manner, you can say that coal is veg and petroleum is non-veg, because it comes from both plant and animal sources. Source wise, this is the source. Then origin wise, we discussed that the origin here has been swamps and wetlands. Basically, the formation started on land, whereas formation here, it started underwater. So origin has been underwater, under oceans, under seas, under lakes, but underwater. So origin has been underwater, source has been again different for both. Then at the another difference that we see between coal and petroleum is that composition wise, coal is made of carbon, whereas carbon plus obviously impurities. And when it comes to petroleum, petroleum is made of hydrocarbons. We are saying that it is a complex mixture of hydrocarbons. And then one more, you can say, on the basis of even the state in which you find them. Coal, we know that coal is in solid state, whereas petroleum can be solid, liquid, or gaseous. Solid, liquid, or gaseous. So that's where they are different. Now, one thing that we need to understand is when we say that it's a complex mixture of hydrocarbons, what do we mean by this phrase complex mixture of hydrocarbons? So, overall, when it comes to petroleum, it is made of hydrocarbons. Hydrocarbons are compounds which have only hydrogen and carbon in them, which do not have any third element. They have only hydrogen and only carbon. In that case, they are called as hydrocarbons. Now, in this case, we are saying that it's a complex mixture of hydrocarbons because there are a lot of different hydrocarbons which are mixed together in making any petroleum product. For example, petrol or diesel. In these cases, you do not assign a chemical formula. Let me ask you a very simple question that you perhaps may have long forgotten. If I ask you, can you tell me the difference between a compound and a mixture? What's the basic difference between a compound and a mixture? If you remember this, class 8th, 9th, 10th science. Yes, Prithvi, you have given the correct answer. Himanshu, you are almost correct. Hemlata, you are also correct. Shalu, you are also correct. So, when it comes to compound versus mixture, in case of compounds, we know that they have a fixed proportion. They have a fixed proportion. And that's why they would have a chemical formula. They have a fixed composition, fixed proportion, and hence a chemical formula. CO2 for carbon dioxide, H2O for water, etc. Right? In case of mixture, you cannot assign a formula because there is no fixed proportion of how much to be mixed with how much of the other element or the other substance. So that's why that's a basic difference. And here when we are saying that it's a complex mixture, it simply means that petrol or diesel cannot have a chemical formula. We cannot assign a fixed chemical formula to petrol or diesel because they are complex mixture of hydrocarbons, meaning that there are various different types of hydrocarbons which are just mixed together in this mixture. So for example, let's say in case of petrol, petrol can in general have 5 to 9 carbon atoms in the mixture. So there can be different types of organic compounds or different types of hydrocarbons which will be mixed, and most of them they will have the number of carbon atoms between 5 to 9. So that basically is what we mean by a complex mixture of hydrocarbons. If you remember, there are things which are called as alkanes, alkenes, alkynes, etc. So all these are various different types of hydrocarbons or even cycloalkanes for that matter. So they all would be mixed together in any petroleum product. Now, when we are talking about petroleum, the formation of petroleum also has happened or would have happened in a very similar way as coal formation happened. That here also we had ancient fossilized materials such as zooplanktons and algae, and they also settled under the sea, under the sea beds or the ocean beds, and then again they also mix with the sediments, same as what happened with coal. And while mixing with the sediments, they are also subjected to high temperature and pressure, same as coal. And now the chemical conversion starts. And in this chemical conversion, so what we see is that first you have the plants and animals, and these plants and animals, they are buried under the sea beds, sea and ocean beds. Then they mix with the sediments. They mix with the sediments, and while mixing with the sediments, their chemical conversion starts. First they convert, so they now are subjected to high temperature and pressure, subjected to high temperature and pressure. And now the chemical conversion starts. First they convert into something which is called as kerogen. First they convert into something called as kerogen. Now this kerogen basically, you can see in a manner, is like a sedimentary rock where conversion of petroleum has started, and first it has converted into this sedimentary or organic rock, which is kerogen. So kerogen is where you can say the conversion now, chemical conversion now has happened up to an extent. Now from this kerogen, further reactions or further processes would take place. Until now what we see is that the carbon chains that we have in all these organic forms, they are very long carbon chains. For example, one compound of this organic hydrocarbon would maybe have 60 to 80 to 100 carbon atoms in the chains. Now these long carbon chains or complex carbon chains, they start to break down. They would break down into 20s and 15s and 10s and 7s of carbon chains. So that is what happens. Now the carbon chains will start to break in this kerogen. After the kerogen formation has happened, now the carbon chains will break, and this is basically something which is called as the process of catagenesis. This process is called as catagenesis. So catagenesis is nothing but the breaking of this catagenesis as a process. This is nothing but the breaking of long carbon chains into shorter chains. So this process is called as catagenesis. So now catagenesis takes place, and now you have smaller carbon chains or smaller hydrocarbons available. Now this further, so you had kerogen first, and then after that the process of catagenesis, and now this further finally goes through another process which is called as pyrolysis. This is called as pyrolysis. Now pyrolysis as a process, basically it's a process where we are looking at a thermochemical decomposition of matter at high temperature and pressure in the absence of oxygen. All right, this is nothing but thermochemical decomposition of organic matter in the absence of oxygen at high temperature and pressure. All right. So this is something which is called as pyrolysis. So lastly, the process of pyrolysis takes place, and this pyrolysis will convert this organic form finally into petroleum. Now, this petroleum that we have right here, this is something that we also call as crude oil. What we get here finally is crude oil. Now, this crude oil is a mixture, of all the different types of petroleum, and it is not usable on its own. By its own, it is not usable. So then in that case, what we see is that now we will have to extract the petroleum products out of this crude oil. So this crude oil will be a mixture of petrol, diesel, kerosene, bitumen, naphtha. All these things will be mixed here together in this crude oil. And now we have to separate out all the petroleum products. And to separate out the petroleum products, we use a process which is called as fractional distillation. The process is called as fractional distillation. Now, first, let's try to understand what is distillation. Distillation as a process is used for separating out miscible liquids. For separating out miscible liquids, meaning the liquids that can mix in one another. If we have to separate them out, then we have to use the process of distillation, right? So distillation as a process will be used to separate these liquids. What do we do in distillation? Also, just understand this, that in distillation what we simply do is that the mixture that you have will be heated, and as you heat the mixture, there will be one uh, which will have a lower boiling point, and the other liquid, let's say, has a higher boiling point. So as you provide the heat, the one with lower boiling point will start to boil first. It will start to convert into its gaseous form first, and it will convert into its gaseous form completely, while the second liquid has just heated. So for example, suppose that there is one liquid, an organic liquid, for example, let's say, has a boiling point of suppose 50 degrees Celsius, and then you have water mixed in it which has a boiling point of 100 degrees Celsius. So one boils at 50, one boils at 100. So obviously the one that boils at 50 degrees Celsius will simply boil and convert into its gaseous form, and the second one, which is at 100 degrees Celsius, obviously will convert into gaseous form later. So by the time suppose you are at 70 degrees Celsius, one liquid completely has converted into its gaseous form, and you only have one liquid in it. So the other liquid which is converted into its gaseous form will be separated, will be separately taken into another vessel, and maybe we will get that liquid separated out in the other vessel. So in this manner, we'll be able to separate these two liquids on the boiling point difference, on the basis of the difference that we have between their boiling points. So this is what distillation is. This is what distillation is. It is the method of separating two or more liquids due to the difference in their boiling points. All right. So that is called as distillation. This is distillation as a process. Now, fractional distillation is a better variant of distillation to be used in cases where normal distillation usage is not possible. Now, this happens when the difference in boiling points is very low. If the difference between the boiling points is not that great, then in that case, we have to use fractional distillation. So, for example, let's say if you have two liquids which have a difference in their boiling points, just 10 degrees Celsius or maybe 15 degrees Celsius and so on, then in that case, separating them out with a normal heating process like distillation is not possible. If the difference in boiling points is huge, at least more than 25 degrees Celsius, that one has a boiling point of 50, another one has more than 75, then normal distillation process is usable. But when it is very low, one at 50 degrees, one at 60 degrees, then in that case normal distillation cannot be used, and we use fractional distillation. So in case of fractional distillation, what we do is that we first heat this entire mixture of liquids to a very high temperature, and then we slowly start to cool them. So separation happens when the mixture is heated at a certain temperature where fractions of the liquids they start to vaporize. So overall what we do is that in case of fractional distillation, I'm just writing it here, fractional distillation is used when the difference in the boiling points of the liquids is less. So what we do is the mixture is first heated to a temperature higher than the boiling points of all the liquids in the mixture, and then cooled slowly. So this is what we do. That first we'll take the entire mixture and heat it to a temperature which is higher than the boiling point of everything that is involved in that mixture, and then we start to slowly cool it down. So this is what we precisely do in fractional distillation of petroleum. That first we take it to a temperature of more than 400 degrees Celsius, and then after that we slowly start to cool it down. So first we'll get bitumen, and then lubricating oil, fuel oil, diesel, paraffin, naphtha, petrol, and lastly LPG. So in this manner, as you cool it down, you will keep getting all these different fractions of petroleum. So this is how we basically make the use of fractional distillation in refining of petroleum into more usable fractions of petroleum. These all products, these all petroleum products are also called as fractions. So this is exactly what we do in case of fractional distillation to get petroleum here, to get, sorry, products of petroleum in this particular scenario. Now let's take a break here. If you have any questions from petroleum, let me know, and then we shall take that break. What are zooplankton? Zooplankton basically is very, you can say, organisms which are found underwater, and these are organisms which are not able to even swim very properly, and they actually consume other organisms which are found underwater. Even if you've heard of jellyfish, jellyfish also can be taken as an example of zooplanktons. So show the previous slide, yeah, with the figure. Boiler slag basically is the leftover of the bottom ash which is in a molten state and has all the different oxides of various metals like calcium oxide and aluminium oxide and all these iron oxides which are all mixed together. Cooling rate depends on what? It depends on the various boiling points of the fractions. So based on that, we would determine how and how slowly the cooling rate should be. We boil petroleum at high temperature and then allowed to cool and settles at the bottom. How do we separate? So separation is completely based on boiling point itself, because let's say at suppose that if you are at let's say 230 degrees Celsius, yeah, or let's say to 50 degrees Celsius, then at 230 degrees Celsius, petrol is a gas. All right, petrol is in gaseous state, but diesel in its liquid state. So now diesel gets separated out. All right, diesel gets separated out while we all still have a naphtha and paraffin and petrol and LPG all mixed together. So that is how on the basis of their boiling point differences, one by one they'll be moved out. Why fuel can't undergo combustion while fractional distillation is going on? The factors that contribute to combustion are taken away from this entire journey, so that combustion cannot happen. For example, we cut off any uh, oxidizer, for example. So we do all this to ensure that it doesn't start burning. Why using high temperature firstly in fractional distillation? Because the difference in the boiling points is very less. So normal heat, providing normal heat will not work. The formation of petroleum is taking place at depth of the sea, but how is it mined? Basically, I mean, first it starts with the detection, and then thereon, once we have been able to explore these, then we start to set up the plants for deep sea exploration. Uh, and obviously, normal mining processes are not used. It's a very different process. We are digging the well to these depths, and then after that, from there on, we get the oil and gas. Can hydrocarbon be alternatively named as carbohydrogen? No, we can't. I mean, this is what the chemical name, the official uh, name is. Flue gas desulfurization means flue gas desulfurization material is the material that we are using in, I mean, not using, but rather producing when desulfurization of coal is done. Desulfurization meaning that we cut out the components which would have the sulfur components which would have led to the formation of sulfur dioxide on combustion. So that is desulfurization. We are removing sulfur from coal. It's a request to all of you. Please ask your questions only once, because I will anyway go to your question. Just that there are many people who are asking the question, so you need not repeat your. All right, so I've taken most of the questions here. So if you have further questions anyway after the class, I mean after the break also we can take the questions. It is almost 2:30. Let's be back by 3:15 and let's continue from there on.